This is Keith Saver doing my final project presentation for deep learning on reinforcement learning for games and simulations. The purpose of this project is to analyze the effect of adjusting the learning rate of a neural net used in reinforcement learning. DeepQ networks are used here due to their proven ability to be effective in games and simulations, and the OpenAI Gym is used to supply a variety of standardized learning environments. A couple other questions being analyzed here are, how does changing the learning rate affect the model's ability to converge on an effective strategy, and does changing the learning rate affect training differently in more and less complex environments? DeepQ networks associate positive and negative rewards with performing different actions across a variety of states. By associating these positive and negative values with the different states, the DQN can slowly learn effective strategies for maximizing positive rewards. They can take a very long time to train and can struggle to converge to a correct strategy. Due to the amount of data required to effectively train them, they're most effective in games and simulations, as infinite data can be procedurally generated. Here, three different environments were used: Cartpole, Acrobat, and Space Invaders. Cartpole is the most simple environment, Acrobat being a slightly more complex environment, and Space Invaders being by far the most complex environment. Here's a sample of results. At the top here, we see the Cartpole with a learning rate of 0.001. The DQN learns Cartpole very effectively, but still does encounter periods of very ineffective performance. Cartpole is learned much less effectively with a higher learning rate of 0.003, resulting in a much lower average score and having longer periods of very low scores. We can see here in the sample results for Space Invaders, even with the learning rate of 0.001, which tended to perform the best on the other environments, Space Invaders was still far too complex for the DQN to learn this environment effectively, even with approximately 10 hours of training. DQNs are very effective at learning environments, and they can be generalized to learn many different environments, but they can take a very long time to train, especially as the complexity of the environment increases.